Hi everyone, welcome to Advent of Cyber Day 14. My name is Toybat and I'm very excited to be doing this with you all. Advent of Cyber is your gateway into learning cybersecurity for free with 24 beginner friendly challenges. And you also get to participate in winning over $150,000 worth of prizes. In order to do this, you need to start the challenge. If you've been joining us, well done. If this is your first time, it's not too late. You just need to start the challenges, answer questions. Once you can answer the questions, the more tasks, the higher your odds of winning. There are different prizes to be won from MacBook, iPhone 17, Akka tools, conferences tickets, certification vouchers, and also Try Acme vouchers. Today is day 14, and we are going to continue our journey of Advent of Cyber and learn about container security. In the story, where it's themed as the sun rose this morning, it had already been decided that today would be another day of chaos in Wareville. At least, that's the feeling all the folks at DoorDasher got. DoorDasher is Wareville's local food delivery site, a favorite of the workers in the best festival company. Well, this morning, one Wareville resident ordered from DoorDasher and only to find that King Male and his bandits, Bunny battalions, had seized control of yet another festive favorite. DoorDasher had been completely rebranded as Operu, a case of culinary impersonation. Now, immediately, one of the security engineers managed to log on and make a script that would restore DoorDasher to its original state. But just before he was able to run it, Sakarot Bain caught wind of his attempt and blocked him and logged him out of the system. All was lost until the SOC team realized they still had access to the system via their monitoring ports, which is an uptime checker for the site. What's our job? Our job is to make sure that we escape this container, we escalate our privilege, and also restore DoorDasher to its original state. In order to do this, we need to start our attack box. We are going to start our virtual matching, and we are also going to have our split screen available. We are going to start the attack box now by clicking on this. Then we'll also click on our start machine. While that is going on, we are going to take an in-depth look at container security. What are containers? In order to understand what a container is, we first need to understand the problem it fixes. Long ago, applications used to be built as one system. All the codes, all the features, everything is bundled as one unit, which is known as a monolith. This came with its own challenges, from installation to troubleshooting and conflict. If it is not about the dependency environment, it is going to be about if one function is faulty, it affects the whole application. Now, a way to overcome this is containers. Containers offers isolation, which means that all the applications and its dependencies are bundled into one unit, known as container. In addition to solving all the above problems, containerization also offers other benefits, which is how lightweight it is and how easy it is to scale these applications. Containers versus virtual machines. Another form of virtualization is virtual machine. Our target machine right now is a virtual machine. Machine virtualization involves having different operating systems running on one host machine, such as our computer. This is done with the aid of an hypervisor. We have application one, which is dependencies and its own peculiar operating system. Same for application two and application three. Everything running on one physical host with the aid of the hypervisor. Containers, on the other hand, requires what we call a container engine. A container engine is the one that runs and manages containers. We have the applications and their dependencies, different applications and their dependencies running on the same host operating system. This makes them very portable and lightweight. So in summary, virtual machines are good for running different operating systems for monolith, while containers are good at deploying scalable, portable microservices. Now, microservices are a way in which applications were being created later on. Applications were now being cut into independent units where it can be easy to scale independently and also easy to maintain. Now, because these parts are bundled as microservices, when one part fails, it does not affect the other parts of the applications. Now, container engine. Like I said earlier, container engines runs and manages containers. And a very good example of container engine is our Docker. Docker is an open source platform for developers to build, deploy, and manage containers. They are very lightweight and portable, like we've mentioned earlier. Docker is able to do this with the aid of its Docker file. The commands it needs are there. Now we move to escape attack and sockets. What exactly is an escape attack? Don't forget that the main security feature that containers offer is isolation. Isolation in the sense that an application and its dependencies are only confined to their own container. They do not have business with other containers or the host operating system. Now, due to some circumstances or misconfigurations, a container may have elevated privileges and have the ability to escape. That is, the application or the code running inside the container will be able to move out and interact directly with other containers and the host operating system. This is where the Docker socket comes in. The Docker socket is like a remote control for the Docker engine. It runs the commands, it gives it the commands to run it, depending on whatever it is. The Docker socket is very powerful in that it can send commands directly to the Docker engine to create containers, to manage containers, to delete containers, what have you. So let's assume we have a container with elevated privileges or that has been misconfigured, and we have what we call a container escape happens. And this container has access to the Docker socket. It can do whatever it needs to do on the host operating system. Our goal today is to investigate the Docker layers and restore the defaced Opera website to its original service, which is the DoorDasher. Now we started our machine. We have the target machine and the attack machine. The next thing we want to do is to check the services that are running with Docker. This is our target machine. We are going to type Docker ps. This command lists all the services that are running. We have 4 containers and we also have 4 services running. We have the uptime checker, we have the Dasher app, we have the where view times, and we also have the deployer. Let's remember that the website has been defaced. Our security engineer already has a script that is going to restore the website to its original state. And we also know that we have access to a monitoring pod, which is known as the uptime checker. The next thing we want to do is to check the main service that runs this at this address using the web application on the attack machine. Now try Acme attack box here. We press enter. Then we come to our web browser, our Firefox web browser. We are going to copy our IP address, including its port number. Ctrl C. We come to our clipboard over here and we paste that. Ctrl V. Once we paste that, we can close our clipboard. Then we also paste it in our web browser and we click on it. We have welcome to Operu, the Easter Bunny's delivery service. Just as we've been told, DoorDasher has been overtaken and we have bad reviews from disappointed customer to angry eater. The next thing that we are going to do now is we are going to explore the services that we have running by coming to the target machine. We need to access the uptime checker pod. And we are going to type docker exec. We are telling Docker that we need to access this and execute commands into a particular container. We are going to do -it. We need an interactive terminal. And we are going to type the name of the container or the service that we are interested in. That's uptime checker, sorry, uptime checker. And we are going to type sh. We need a shell. Now we are in. Now that we are in, we are going to check if we have sockets access. ls, we want to list, then la means we want more details and also to show hidden files. Then this is where we get to access our Docker socket, var run docker.sock. We want to know if we have access to that. Okay, great. We are root. That means we have access and we can do whatever we need to do. The next thing we'll try to do is see if we can run Docker commands in this container, and we are going to do Docker ps. And we can see that we can run Docker commands in this container. Now, we will try to access our deployer container. This is the container that has the scripts that can restore our website to its original state. So next thing we do, we run Docker exec. We want to run commands and we need an interactive terminal -it. The name of the container is deployer. And also we want a bash shell, which is a more powerful shell. Nice. Now that we are inside, we are going to type who am I to know who we are. We are deployer, good. And we are going to try to run the recovery script by typing sudo, that's elevated privilege, recovery _script .sh. Okay, restarting Dasher app container. Recovery complete. Dasher has been restored. The hackers have been defeated. Nice. So as a reward, we should be able to find a flag in the same directory as the script. What we are going to do is we are going to list the content of the directory lsla. Want to list the content, give us more information, and also show hidden files of the root directory. Nice. We can see that we have our flag.txt over here, right? We can see that we also have our recovery script that we just used over here. Nice. Now the next thing we'll do is to print out the content of the flag using cat command. This shows us the content of the flag. Cat flag.txt. Great, we have try acme docker escape success. We're going to come here and try acme curly bracket docker escape success. Yep, and we are good to go. What we've been able to do is we access our own container that is running on Uptime Checker. We check if we have access to the Docker sockets. Once we saw that we had access to the Docker sockets, we escaped our container into the other container called deployer, where we are now able to run our recovery scripts. Great. The next thing we'll do is we are going to refresh the website and see for ourselves that it has been restored. Welcome to Opero. Let's refresh. Oh, welcome to DoorDasher. Nice. DoorDasher has been restored. Next thing, as a reward, we should find a flag. We've done that. So what questions do we have to answer? What exact command list running Docker containers? That's Docker, okay. Okay, remove from caps lock Docker, PS. Nice. What file is used to define the instructions for building a Docker image? That's the Docker file. Nice. What is the flag? We found the flag. There is a bonus question here. There is a secret code contained within the new site running on port 5002. We are going to come here and change our port from 001 to 002, and we are going to press enter. This code also happens to be the password for the deployer user. We are going to scroll to the new site and see if we find anything out of the ordinary. Okay, we can see something in red over here, deploy. We have master. Oh, okay, let's try that. Deploy master 2025 exclamation mark. Check. Nice. We got it. If you like this content, there are plenty more where this came from, and try out the container vulnerability rooms as a starter and move on. Now we are going to check these, and with this, we've come to the end of container security. Dot Dasha's demise. I hope you had a great time. Thank you very much.